This six-story tall structure is not a factory or workshop. It is actually the engine of the world's largest LNG-based container ship. The engine is so huge from the inside that workers can easily walk around inside it. This engine powers a propeller that is almost as tall as a double-story house. And of course, since it is the engine of such a massive container ship, it consumes an enormous amount of fuel. It uses nearly 100,000 liters of fuel just to start. Surprisingly, its fuel tank is so large that 6 Olympic-sized swimming pools could fit inside it. The ship is filled with around 20 million liters of liquefied natural gas. Today, you will learn about a mega project whose construction has truly pushed the limits of human engineering. Welcome once again to Nexus of Knowledge Video. We are living in the 21st century, yet 90% of international trade is still transported through the sea, whether it is something as small as a needle or as large as a car. To understand this scale, consider that according to flight radar, at any given moment, there are 15,000 to 20,000 airplanes flying in the sky. But if we check marine traffic, at the moment this video is being made, an astonishing 38,000 cargo ships are traveling across the world's oceans. Humans have already built extremely large cargo ships. Even larger ones could be built, but such ships would not be able to pass through major canals like the Suez Canal or the Panama Canal. So now, the competition is not about building bigger ships, but about making ships that are more fuel efficient. And this is exactly what the French shipping company CMA-CGM aimed to do. They wanted to build the world's largest environment-friendly ship, one that does not run on diesel or HSFO, but instead on LNG. The ship itself is 400 meters long, which is about the same length as 4 football fields placed in a straight line. Its width is 61 meters, and its height is even taller than the Qutb Minar. The total weight of this ship is equal to 7 Eiffel Towers or about 11,500 African elephants. In simple words, it weighs around 70,000 tons, and that's without any containers loaded on it. This ship can carry a total of 23,312 containers. To understand how huge this number is, imagine placing all these containers in one straight line. They would form a line about 150 kilometers long. But the real challenge was not just building one massive ship. CMA-CGM had to build 9 such ships, and that too within only 2 years. For this enormous task, a shipyard in Hong Kong was selected. The shipyard is 4 kilometers long and looks like a small industrial city. Around 6,000 workers from different countries work here day and night, each assigned specific tasks. Normally, it takes around 18 months to build just one ship. So how could 9 ships be built in only 2 years? The simple answer is, the ships were built in sections called blocks. The foundation of every ship is made from steel sheets, which are used because they don't rust easily. One ship required 12,660 steel sheets. These sheets were cut using a special laser beam that reached a temperature of 18,000 degrees Celsius, 3 times hotter than the surface of the sun. This laser cuts steel as smoothly as a knife cuts butter. For one ship, a total of 880 kilometers of steel strips were cut. After cutting, the steel sheets were joined together to build the blocks. These blocks varied in size. Some were the size of a room, while others were much larger. The amazing thing is that the blocks already have pipes, wiring, and other fittings installed inside them before they are even attached to the ship. This part of the ship is the rear section, built by combining 5 large blocks. It weighs around 790 tons, which is equal to the weight of 2 train engines. To lift just this one section, 2 massive joint cranes were used. The block was placed onto the ship's existing structure with extreme precision. Even a mistake of 1 millimeter could ruin months of hard work. Once all the blocks were positioned correctly, the next stage began, an endless cycle of welding. Surprisingly, a total of 1,250 kilometers of welding was done on a single ship. After welding, every joint was inspected very carefully because the harsh waves of the ocean do not forgive even the smallest weakness. Everything up to this point was just the hull and the block assembly. The real marvel lies in the ship's engine. This ship will not run on traditional oil or diesel. It is designed to run entirely on LNG, liquefied natural gas. This is a huge environmental achievement. Compared to oil, LNG releases 99% less sulfur dioxide, 91% less air pollution, and 20% less carbon dioxide. This is a major step toward making sea travel cleaner and more environmentally friendly. But if CMA CGM truly wants to bring this revolution to the shipping industry, they must pay a heavy price. The biggest challenge was how to store LNG in liquid form. They needed a fuel tank that could keep LNG at minus 161 degrees Celsius, so it remains in liquid state. If it warms up even a little, or if the tank's insulation is not perfect, the LNG will turn into gas, expand, and the entire system can fail. This ship has to travel all the way from Asia to Europe without refueling, so the LNG tank had to be extremely large. But how large? Surprisingly, this is the largest LNG fuel tank ever built in history, with a volume of 18,000 cubic meters. It is so huge that 6 Olympic-sized swimming pools could fit inside it. In total, the tank can store around 20 million liters of LNG. However, the biggest challenge was not just building such a massive tank inside the ship. The real challenge was protecting this tank from heat, basically creating a giant thermos the size of 6 swimming pools inside the ship. It took the company about 9 months to build this fuel tank. Multiple layers of insulating materials were added to the tank walls to protect it from outside heat. Then came the most critical stage, leak testing. The tank had to be absolutely airtight. For this, the workers used a simple but effective method. They applied soapy water on the joints, placed a glass cup over each joint, and used a compressor to suck all the air out from inside the cup. If a joint was weak, outside air would enter through the leak because of the vacuum, and soap bubbles would appear. Any leaking joints were identified and repaired. After leak testing, the final insulation layer was added. This layer is a special steel membrane that is only 1.2 millimeters thick. When the extremely cold LNG at minus 161 degrees Celsius comes into contact with it, the steel shrinks. The wavy pattern of the membrane allows it to shrink and expand safely without cracking. You will be surprised to know that this insulation technology is also used in space stations. After nearly 8 months of constant work, this giant structure, the world's largest thermos, was finally completed. Now let's move to the ship's engine. This is the largest natural gas-powered engine ever built. It is 20 meters tall, which is the height of a 6-story building. Weighing more than 2,000 tons, this engine produces 85,000 horsepower. It is so huge that the maintenance staff can walk inside it. Bringing this engine to the shipyard was a massive challenge in itself. It had to be transported in 6 separate pieces. Its most important part is the crankshaft, the component that transfers power from the engine to the propeller. This crankshaft alone weighs 220 tons. To move it, a special remote control platform with 140 wheels was used. Installing it required accuracy down to the millimeter. The engine contains 12 pistons, each 1 meter in diameter. The crankshaft was carefully attached to all these pistons. This engine will drive the large propeller mounted at the back of the ship. This propeller is a single cast piece weighing 92 tons, and it stands about 10 meters, 33 feet tall. The engine's power reaches the propeller through a long propeller shaft. It is extremely important for this shaft to be perfectly straight. Even a slight bend can create dangerous vibrations when the engine is running at high RPM. To check this, a special blue dye is applied to the shaft before fitting it into the propeller. After removing it, engineers can see exactly which parts of the shaft made contact with the inside surface of the propeller. This shows whether everything is aligned perfectly. This blue dye test helps the engineering teams identify the exact spots where the shaft did not touch the propeller surface and where it experienced extra pressure. Based on these marks, adjustments are made until everything fits perfectly. Once the entire structure of the ship was completed, the next step was to protect it from the harsh marine environment. This meant applying a special paint coating. The salty seawater waves, and constant friction can eat away at steel, and a rough surface also increases fuel consumption. That's why a special protective paint was used. A single ship required around 1 million liters of paint, covering a total area of 9,500 square meters, which is more than twice the area of Vatican City. After this, the final and tallest block was installed, the command bridge. This is the brain of the entire ship, where the captain and crew control everything. On this 400-meter-long vessel, a system called Smart Eyes is installed all around, allowing the captain to get a full 360-degree view while sitting on the bridge. Finally, after 1.5 years of nonstop effort, the first ship, Jacques Sade, was ready. During the next 15 days of intense sea trials, every single system was tested. The engine speed was checked, emergency braking was tested, navigation systems were verified, and the entire structure was inspected for any leaks. Even a massive anchor was deployed and tested. To give you an idea of its size, just one link of the anchor's chain weighs 300 kilograms, and the entire chain weighs as much as 60 African elephants. After all tests were completed, the ship passed the sea trial successfully. The engineering team's dream of building low-carbon emission ships finally became a reality. The shipyard won the race against time by completing 9 of these mega container ships in record time. This story is not just about constructing a mountain of steel. It is the story of thousands of workers, their skill, dedication, and relentless hard work. Now, these giant ships are ready to rule the oceans, and they will do it in a much cleaner, more eco-friendly way. These megaships prove that when humans truly decide to achieve something, they can even make steel mountains move across unforgiving seas. We hope you enjoyed this Nexus of Knowledge video. Thank you so much for your kind comments, likes, and shares. See you in the next amazing video.